All right, hello, hello. Today we're going to go over Unit 7, Lesson 7, Surface Area of Spheres. So it's like if you were to wrap something around a ball, right, like a basketball or, any kind of sphere, how much area would that take up? Okay, so spheres are unique in that they have no edges, no faces, and no vertices. Okay, and the surface area formula is 4 times pi times the radius squared. Okay? Um, the best way for us to work on this is we're going to get straight into examples. So let's go ahead and do that now. Number 1, find the surface area of a sphere with a diameter of 40 inches. Leave your answer in terms of pi. So this is a new thing for us, and I'm going to show you what that means when we solve. Okay? So first off, we've got our formula here, right? Surface area is equal to 4 times pi times the radius squared. Well, we were given a diameter, and remember, diameter is twice as long as the radius, but we need the radius for our formula, so we need half of this, which would be 20 inches. So to fill this in, we've got 4 pi times 20 squared. Okay, well 20 squared, that means 20 times 20. That's 400. So really we have 4 times pi times 400. I'm already going to run out of room. But right now I'm leaving pi alone. That's what this means, like in terms of pi. I'm just leaving pi in there, almost as if it's a variable. Okay? But so next I can do 4 times 400 though, and I'll come up here. That gives me 1,600 pi. And then it was in inches, and they would be squared. Okay, surface area is always squared. That's a two-dimensional feature. Okay, so we'll say surface area, and this is what it means in leaving it in terms of pi. So we're just leaving pi alone. So this is actually more exact than using 3.14. All right? Let's try that again. A cube box is 20 centimeters by 20 centimeters by 20 centimeters. What is the surface area of the largest size sphere that can fit in the box? Leave your answer in terms of pi. So there's a few things. It's a cube box, right? So let's draw that. All right, sometimes drawing a picture to understand what is being said can be really, really helpful. So this said it was a 20 by 20 by 20 box. But what we're pretending is that there's a sphere inside there, okay? And just to pretend like that's a three-dimensional shape, okay? So that means we could technically fit a sphere that has a diameter of 20, right? It could be 20, and what were they? Centimeters. It could be 20 centimeters across. So that would give me, 20 centimeters for my diameter. But according to my formula, I only need the radius. So if my diameter is 20, that means my radius is 10. And then we can just use that same formula. The surface area is equal to 4 times pi times the radius squared. Well, we've got 4. It said to leave it in terms of pi, so I'm just going to leave pi in my formula. And then this is going to be multiplied by 10 squared. Well, 4 times pi, and then 100 is 10 squared, right? 10 times 10. Okay. I could multiply these together, right, because of the commutative property of multiplication. It doesn't matter the order. 4 times 100 is 400, and that is being multiplied by pi. And again, these were in centimeters. We're talking about area, so they would be squared. Okay? All right. Last problem. use the formula for the surface area of a sphere, okay, that's what I've got here, to find the surface area of a basketball that has a diameter of 9.2 inches. Use 3.14 as pi and round to the nearest hundredth if necessary. So this time we're plugging 3.14 into the formula. Again, we're given a diameter, right? I'll write that over here. Our diameter is equal to 9.2. Well, let's see. Half of 9 is 4.5. Half of 0.2 is 0.1. So the half of 9.2 would be 4.6. And these are inches. So that's my radius. So this time I'm going to have 4 times 3.14 times 4.6 squared. Okay? So first I need to apply my exponent, right? According to the order of operations. Let's see, where do I have the most room? There we go. So I can do 4.6 times 4.6. That's what it means to square a number, right? So we've got 4 times 3.14 times 21.16. So then I'm going to do times 3.14. I kind of went backwards, but that's okay. So now I have 4. I multiplied these two together on my calculator. So now I have 4 times, let's see, we've got 66.4424. So multiply by 4 gives me 265.7696. It asked me to round to the nearest hundredths place if necessary, meaning like if it went past the hundredths place. And so here's my hundredths place. In order to round to this place value, I'm going to look to the right of it. Since it's 5 or higher, the 6 is going to get bumped up to a 7. So this would be 265 and 77 hundredths. And these were inches squared. Okay? All right, as always, I hope that helps to see some of these problems written out. And if you need anything else, just let me know.